A live response is a crucial process in cybersecurity incident response, playing a vital role in mitigating threats. It involves analyzing systems and collecting data while the incident is still happening, ensuring timely action. This real-time approach helps understand the attack, limit damage, and preserve evidence, which is essential for post-incident analysis. Live response is needed in several situations, each requiring a tailored approach. Incident detection is a primary trigger, often initiated by automated systems. When security tools or procedures detect suspicious activity, a live response helps determine if it's a real attack or a false alarm, providing clarity. If a system compromise is suspected or confirmed, live response becomes critical to contain the threat. It helps determine the extent of the breach, identify compromised accounts, and gather evidence for remediation, ensuring a thorough response. Legal and regulatory frameworks often mandate specific actions in case of security incidents, making live response indispensable. Live response aligns with these requirements by ensuring proper evidence collection and documentation, which is crucial for compliance. Proactive monitoring, although not always triggered by incidents, benefits from live response techniques, enhancing security posture. Regular live response exercises help test incident response plans, identify security gaps, and improve overall preparedness, ensuring readiness for real threats. Selecting the right tools is crucial for effective live response. Several factors should be considered. Compatibility with the target system is paramount. The tool should function seamlessly with the operating system and software being investigated. Functionality is another key aspect. The tool should offer a comprehensive suite of features for data collection, analysis, and preservation. Portability is vital, especially when dealing with multiple systems or remote investigations. The tool should be easily deployable and operable across different environments. Reputation and trustworthiness are essential considerations. Tools from reputable vendors with a proven track record in the cybersecurity industry should be prioritized. During a live response, data collection is paramount. Prioritizing volatile data is critical as it disappears when a system shuts down. RAM contents are highly volatile and contain valuable information. This includes running processes, login credentials, and encryption keys. Running processes offer insights into malicious activities. Analyzing them helps identify suspicious programs or unauthorized modifications. Network connections reveal communication patterns, potentially uncovering connections to malicious servers or command and control infrastructure. Identifying logged-in users and their activity timestamps helps track suspicious actions and potential insider threats. While less volatile, non-volatile data should also be collected. System logs, configuration files, and file metadata provide valuable historical context and evidence for incident investigation. Adhering to best practices is crucial for successful live response data collection. Meticulous documentation is paramount to ensure accuracy and reliability. Every step from tool deployment to data extraction should be thoroughly documented to maintain a clear audit trail. This helps in verifying the process and ensuring accountability. Using right blocking tools is essential to prevent accidental modification of the target system during data acquisition, preserving the integrity of evidence. This step is critical in forensic investigations. Hashing collected data using cryptographic algorithms like SHA-256 ensures data integrity and verifies that the collected evidence hasn't been tampered with during or after acquisition. This provides a secure method to validate data. Minimizing system interaction is crucial to avoid inadvertently altering data or tipping off attackers. This practice helps maintain the original state of the system. Using specialized tools and techniques minimizes the footprint on the target system, ensuring that the evidence remains unaltered and reliable. Securing collected data is paramount. Proper storage and handling prevent unauthorized access and potential data breaches. Encrypting data in transit and at rest protects sensitive information and maintains its confidentiality. This is essential for safeguarding data against unauthorized access and ensuring privacy. Section 5. Live response on Windows systems. Live response procedures vary depending on the operating system. On Windows systems, specific tools and techniques are employed. Volatility is a powerful open-source framework for RAM analysis. It allows investigators to extract valuable artifacts from memory dumps, including running processes, network connections, and login credentials. FTK Imager and Encase Forensic are commercial forensic suites that offer comprehensive capabilities for data acquisition and analysis on Windows systems. They provide tools for creating forensic images of hard drives, collecting volatile data, and analyzing system artifacts. Using the built-in command line interface, investigators can leverage commands like netstat to view active network connections, tasklist to list running processes, and logman to collect event logs. Section 6. Live response on Unix-based systems. Live response on Unix-based systems such as Linux and macOS involves a different set of tools and commands tailored to these environments. The DD command is a powerful utility for creating forensic disk images, capturing the entire contents of a hard drive or partition. This is crucial for preserving evidence in its original state. The memdump command, often available as part of live response distributions or forensic tools, allows investigators to capture the contents of RAM, preserving volatile data that could be lost upon shutdown. Network analysis tools like TCP dump and Shark enable capturing and analyzing network traffic in real time. These tools are essential for monitoring ongoing activities. These tools help identify suspicious connections, data exfiltration attempts, and other network-based indicators of compromise, or IOCs, which are critical for threat detection. System logs stored in files like /var/log/messages and /var/log/secure provide valuable information about system events, user activities, and potential security issues. Analyzing these logs can reveal unauthorized access attempts and other anomalies. Section 7. The importance of network monitoring. Network monitoring is a critical aspect of cybersecurity, providing visibility into network activities and aiding in detecting and responding to security incidents. It involves capturing, recording, and analyzing network traffic to identify suspicious patterns, anomalies, and policy violations. Effective network monitoring serves several crucial purposes. It allows organizations to detect and respond to security incidents in real time, mitigating potential damage and data loss. By analyzing network traffic patterns, organizations can identify unusual activities such as unauthorized access attempts, malware infections, and data exfiltration. Network monitoring assists in troubleshooting network performance issues by providing insights into bandwidth usage, latency bottlenecks, and network device health. Section 8. Setting up a network monitoring system. Setting up a robust network monitoring system involves several key steps. The first step is choosing appropriate network monitoring tools based on organizational needs, network infrastructure, and budget. Tools range from open-source solutions like Zeek and Security Onion to commercial offerings like Splunk and SolarWinds. Deploying sensors strategically across the network is crucial for comprehensive visibility. Sensors should be placed at critical points, including network gateways, server segments, and DMZs to capture traffic flowing through these areas. Configuring alerts based on predefined rules and thresholds is essential for timely incident detection. Alerts should be triggered for suspicious activities like port scans, brute force attempts, and known malicious traffic signatures. Section 9. Analyzing network data and logs. Network data analysis is crucial for making sense of the vast amount of data collected by monitoring tools. Effective analysis helps identify traffic patterns, detect anomalies, and gain insights into network behavior. One common technique is baseline analysis, which involves establishing normal network traffic patterns and then looking for deviations that might indicate suspicious activity. Analyzing network logs from various sources, including firewalls, routers, servers, and intrusion detection prevention systems, or IDS/IPS, provides valuable insights into security events, policy violations, and system health. Centralizing logs from different devices into a central repository simplifies analysis and correlation. Tools like Elasticsearch, Logstash, and Kibana, also known as the LK-Stack and Splunk, are widely used for log centralization, parsing, and visualization.